Assalamualaikum. Okay, how are you today? All right, so today we're going to learn about isotopes. Okay, I'm going to use this virtual reality program called VRTIF. Okay, so let's explore the side of the VRTIF and have some fun, okay, with isotopes. Yeah, so students, today from our learning standard, at the end of this lesson, you will be able to deduce the meaning of isotope. So we're going to use a program called VRTIF, which is a virtual reality learning platform. I hope you'll enjoy the class today. In this VRTIF program, our learning objective for today is to define isotope, to identify isotopes of different elements, and to calculate the number of protons and neutrons in different isotopes. Let's do some exploration. Okay, how do we define isotopes? Okay, students. Okay, let's look at this interactive activity, okay, using the VRTIF module. Okay, so I'm going to click start. Ah, that's the element of carbon. So you can like open it, yeah, open the atom of carbon and you see some small flying particles. Okay, move away periodic table. Okay, now let's see this flying particles, subatomic particles to be exact. Okay, there's electrons. Okay, and then there's nucleus. Okay, now can we count the electrons? Yeah, that's 1, 2, 3, 4, 5, and 6. So how about the protons? Okay, let's see. Proton is in the nucleus. Yes, okay. All right. Okay. Can't really see the protons yet. Hey, there's another one over here. What is that? It looks like the same atom. There's nucleus. You can see the blue and red. Okay. One of it is proton and one of it is neutron. Okay. So you can see. The yellow dots are electrons. Yeah. Over here we have 1, 2, 3, 4, 5, 6 electrons too. So what is this? So we have one carbon atom here with 6 electrons and another carbon atom here with also 6 electrons. Okay, let's see. Oh, there's carbon 12 and carbon 13. Now what is that? Okay, they are isotopes. Okay, how can they be isotopes? What is isotope actually? Oh, okay. So you see here now. Is there a difference between carbon 12 and carbon 13? Okay, so for carbon 12, okay, you can see that there's 6 protons. For carbon 13, there's 6 protons as well. Okay, and remember earlier, there are 6 electrons for carbon 12 and there are also 6 electrons for carbon 13. But if you look at the number of neutrons, for carbon 12, there's 1, 2, 3, 4, 5, and 6. But for carbon 13, there's 1, 2, 3, 4, 5, 6, and 7. So you see there's a difference between carbon 12 and carbon 13. They're basically the same atom, but with the same number of protons and different number of neutrons. Okay, this is another atom. There's protium, deuterium, and tritium. But if you look at the symbol of the element, all of them have the same symbol, which is H. But protium has 1, 0, deuterium 2, 1, while tritium is 3, 1. What is that? The same green dots. Protium, deuterium, and tritium have the same number of electrons, which is 1. What about the proton? Okay, let's see. Students, okay, if you look from this diagram, you can see that there's 1 proton for protium, but there's no neutron, 1 proton for deuterium, and there's 1 neutron, while 1 proton for tritium, and there's 2 neutrons. Now we can relate it to the atomic number. Atomic number for protium is 1, for deuterium is 1, for tritium is 1 too, because atomic number is the same as number of protons. How about mass number? Okay, the mass number is equals to number of protons plus number of neutrons. So every element here, okay, every atom here has 1 proton each, but protium has no neutrons, so the mass number is 1. Deuterium has 1 neutron, so the mass number is 1 plus 1, which is 2. While tritium, the mass number is 3 because there's 1 proton plus 2 neutrons. So the representation here is 1, 2, and 3, correct? Okay, the top number is the mass number, 1, 2, and 3. But the bottom number is a little bit wrong here for protium. Yeah, but that's okay, all right? We can identify that. Okay, it should have been 1, 1, 1. Yeah, for protium, deuterium, and tritium. Okay, students, let's play a game. I'm going to show you this game, okay? And then let's see how you're going to learn from it. Okay, shall we start? I'm going to click on oxygen. Ooh. Okay, students, you're provided with an atom, neutrons, and protons on your left. Follow the instructions to play this module. Oh, there's oxygen here with the symbol and the mass number is 16 while the proton number is 8. Stability stable, which means it's a stable atom. Mass number 16, yes, as I've said earlier. Natural abundance 99.757%. Awesome. Okay, which is why oxygen is so useful. What are the other usage of oxygen that you can think of? Yeah, it's for combustion, it's for cell respiration. Yeah, I've mentioned earlier. So you can see here we have neutrons and protons. Number of neutrons, okay, there's 8 neutrons and there's 8 protons. Okay, let's see how. You are required to make an oxygen-17 isotope of the oxygen atom. You can either remove the suitable number of neutrons and protons from the nucleus or add them to the nucleus from the panel on your left. Okay, let's see. I have 8 protons. Okay, for an atom that is stable, the number of protons and electrons should be the same. So here I have 1, 2, 3, 4, 5, 6, 7, 8. It's so hard to actually count the electrons, yeah, because it's moving. Okay, but you can't blame the electron for moving because they're super small and their mass is super little, so they can move fast. Okay, protons and neutrons are in the nucleus, so they're not going anywhere. Okay, so what must I do? Yes, okay. I think I should add the neutrons because the number of protons must be the same. If it's oxygen, 16 or 17 or 18, the number of protons must be the same. So we don't add any more protons. So we try to add neutrons now. Ooh, I can click it that way. Okay, I'm going to put it inside now. Let's see what happens. Okay, now I have 9 neutrons and 8 protons. That would be 17, yeah, for the mass. Okay, let me click submit. Because it says here oxygen 17. Okay, so I have a total now of oxygen 17. Okay, let's click submit and see what happens. Yeah, well done. So because of your assurance, students, okay, we have successfully made the oxygen 17 isotope. Okay, congratulations. Okay, oh, now there's a new activity. Okay, you are required to make an oxygen 18 isotope of the oxygen atom. Okay, let's try. It's 8 and 8, but now we have oxygen 18. So what must we do? Okay, I think we should add more neutrons. What do you think? Two more? Okay, I'll add two more. Oops, 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 oops. Okay, that's one. Okay, and now there's 9. 9 plus 8 is 17. But we need 18, so we need two more. I'm going to add another one in the nucleus. Okay, let's check the count. Yeah, okay, there's 10 neutrons now. Well, there's 8 protons, so total is 18. Okay, let's click submit and see what happens. Well done. You have successfully made the oxygen 18 isotope. Awesome. Okay, so we can choose now a different element. Okay, we have studied oxygen. Okay, why not we choose another element, okay, to study the properties of the isotope. Okay, we have studied hydrogen, we have looked into carbon. So why don't we look into something else? Nitrogen? Okay, let's try nitrogen. Nitrogen has mass number of 14, proton 7, neutron 7. Do you know the percentage of nitrogen in the air? There's 78% of nitrogen in the air compared to only 21% of oxygen. Students, let's try to play this module again. Okay, you are required to make a nitrogen 15 isotope. Okay, remember, we will never ever disturb the proton or the electrons. You can only add neutrons. Yeah. Okay. So I'm going to add neutron again. How many should I add? One. Okay. One. Okay. Let's check. Yeah. Now there's 8 neutrons and 7 protons. So a total of 15. Yeah. So I think we got it right now. Okay. Let's click submit. Well done. Yes. Thank you, students. You have successfully made the nitrogen 15 isotope. Okay. So we've been nitrogen. Do you want to see what happens if you actually add something else like protons? Maybe we can try one. Okay, let's take lithium. So lithium, the mass number is 7, the proton number is 3, and the neutrons is 4. Yeah, lithium is a member of group 1 elements. Okay, it's highly reactive upon contact with oxygen and water. You will learn more about this in the periodic table. Okay, so here it says you're required to make a lithium-6 isotope of the lithium atom. I did mention just now what happened if you accidentally add more protons. Bring it to the middle, click submit. Try again, select the correct number of protons. Okay, now you see the number of proton cannot be 4 because the number of protons of an isotope. The definition of isotope can be defined by this activity. So now we know you cannot add proton. So what do we do now? Take out one proton. Take one proton out. And now we have 3 protons and 4 neutrons. Our task is to make lithium 6. So you cannot add protons to it, but can you remove a proton to make it 6? Okay, let's try to remove a proton to make it 6. Okay, I'm removing one proton. So now you see the number here is 4 and 2. Okay, so it's 6. Can I click submit? Oh no, try again. Select. So it means that lithium has a proton number of 3. You cannot change that. So it has to be 3 all the time. So put back the proton inside. Okay. But now there's 3 protons and 4 neutrons and a total of 7, but you want lithium 6. So you can only put in neutron or take out the neutron. I'm going to take out one neutron. Okay. So now I have 3 plus 3 and that's 6. Well done. Okay. You have successfully made the lithium-6 isotope. Dear student, we have done an activity earlier using the VATIF module to learn about the definition of isotopes. From the module that we have done earlier, okay, we can actually define isotope into atoms of the same element with the same number of protons, okay, but different number of neutrons. So the keyword here is it has to be atoms of the same element and then same number of protons and different number of neutrons. And we have few examples just now. So you have seen carbon 12, carbon 13, carbon 14. You have seen hydrogen, hydrogen 1, hydrogen 2, hydrogen 3, and also oxygen 16 and oxygen 17, and a few more other elements. These isotopes, carbon 12, carbon 13, carbon 14, hydrogen 1, 2, and 3, oxygen 16 and 17. So all of them have the same number of protons. I guess for carbon, we have 6 protons. For hydrogen, 1 proton each. And for oxygen, we have 8 protons. They have the same number of protons, okay, different number of neutrons. Okay, how to get the number of neutrons? So you minus the mass number to the protons, yeah? So you will get 6 here, okay, for carbon 12, and 7 neutrons for carbon 13, and 8 neutrons for carbon 14. Whereas for hydrogen, there's 0 neutron for hydrogen 1, and 1 neutron for hydrogen 2, and 2 neutrons for hydrogen 3. And for oxygen, we have 8 neutrons for oxygen 16, and 9 neutrons for oxygen 17. So they fulfill this part. Now, are they atoms of the same element? Yes, they are, because these are all carbon. You don't change the name, okay? These 3 are all hydrogens, and these 2 are oxygen. So students, I hope you enjoyed today's activity of learning about isotopes. So up next, okay, we're going to learn about the usage of certain isotopes. Stay tuned. Bye.